A major focus of science on the International Space Station is to learn about how extended exposure to the spaceflight environment impacts a human body, from its bones and muscles to the eyes, the cardiopulmonary system, and the brain and nervous system. One new experiment in that area is called Spaceflight Effects of Neurocognitive Performance, or NeuroMapping for short. And we're going to be talking next with Principal Investigator Dr. Rachael Seidler of the University of Michigan. She's joining us to tell us a little bit more about that research. Thanks so much for joining us, Rachael.
Sure. Good morning, Brandi.
Morning. Well, why don't we start with something simple, and maybe you can explain to us what or why we suspect long duration spaceflight causes changes to the brain.
Sure, right. There are two lines of evidence that led us to develop this study. One is that there have been numerous animal models flown in space that have shown changes to brain structure and function, particularly in brain regions that are involved with sensory motor control. And the other reason why we think there are likely changes in brain structure and function is that we know there are extensive changes in sensory motor behaviors, particularly those that rely on the vestibular system. And when we see dramatic changes like this on Earth, we know it's typically accompanied with some kind of neuroplastic changes in the brain.
So that's actual physical changes or just changes in the way the brain works?
Both. We'll be looking at both. With MRI, we can look at structural metrics of the brain. So, for example, are there regional changes in gray matter volume, which tends to reflect things like synaptic changes that are occurring with behavior. We also will do something called diffusion-weighted imaging, where we can look at large white matter tracts in the brain. And then we will also do functional imaging, so we can look at the various networks that the brain recruits to perform a given behavior, and whether there's a change in the networks that are relied upon for various tasks from pre to post flight.
So I know a lot of, there's a lot of pretty sophisticated equipment on board the space station, but probably not everything you need to do all that. What can they do in space?
Right. So we don't have an MRI scanner on the space station, at least not yet. So we're doing all of the brain scanning pre and post flight, a couple of time points before people go up, and then several time points when they get back, so we can look at recovery of brain structure and function as well. So what the crew are doing on station is a subset of our behavioral tests. And they're doing this at 3 time points throughout their mission. So Verts did his first NeuroMapping behavioral testing yesterday. And the tests that he's doing include a mental rotation test. So we show him different cube shapes on the screen. He has to mentally rotate these shapes and indicate whether they match a target or not. We also are asking him to do some dual tasking with cognitive and motor tasks. So we have him do tasks one at a time, and then he has to put them together and do them at the same time. And then we also have a manual sensory motor adaptation task where he uses a small joystick to hit targets on a computer screen that's displayed in front of him.
Okay, and I guess I know that Barry Wilmore was going to be taking some photos of Verts as he was going through some of those tests this morning. Is that part of the actual test, or is it just to verify that everything looks like it's supposed to?
Yeah, the photos are to help us document that everything's going fine. We have a couple of different configurations that we ask the crew to perform these tests in. So for one, they have their feet in straps, so their feet are pressed onto a surface. And oftentimes when the crew do this, they actually have an illusion that up is up and down is down. And we're wondering how this orientation anchoring will affect their ability to perform our tasks. So we also have another configuration where they do the task and they're just floating in space, and they're anchored to the equipment with a tether. So the photo is to document that everything's set up appropriately in terms of these two configurations. And I haven't had a chance to download the figure yet, or the photo. I've heard they were taken, but we haven't had a chance to look yet. We're very excited to see how it went.
Well, it sounds like really interesting research. Is it something that you think you will help you develop countermeasures, or is it just good knowledge to have as you're planning for what types of activities crew members do, or that sort of thing?
Yes, so to start with, Brandi, this is really a risk assessment study. No one has yet looked at how spaceflight affects the brain, whether there's actually atrophy that occurs or if it all seems to be a compensatory plasticity or perhaps a combination of the two. So we don't really know what the risk level is. So really, this study is tracking what changes take place in the brain, and then we will also document the time course of recovery. And then this will help us to understand how significant of a risk is this. What kind of countermeasures do we need to think about evaluating and implementing? We do have a parallel study that we're conducting here on Earth in one of NASA's bedrest analog environments. And we're seeing a lot of changes there in brain structure and function. So we really think we'll see some parallel effects with spaceflight.
Well, it sounds fascinating. Are there benefits to those of us here on Earth as well?
Yes, certainly you can think about a lot of the changes that we see in behavior with flight come from alterations in vestibular processing. So the vestibular system is the small organ in the inner ear that helps you to maintain your balance and orientation. And this is a system that shows declines with age and contributes to falling. There are also patients that have different lesions to the vestibular system. So a better understanding of how we adapt to conditions in which the vestibular system is functioning differently, as well as just unloading of the body and reduced somatosensory inputs, I think will be really important for understanding not only healthy aging, but also some of these vestibular conditions, and as well for people that are on long duration bed rest or for some reason having a substantial drop in their activity and sensory inputs.
Okay, well, we will look forward to hearing more about that as you continue on with the research. Thank you so much for joining us. And again, that was Dr. Rachael Seidler, who is the principal investigator for the NeuroMapping experiment. Thanks again.
It was my pleasure, Brandi.